The first contradiction is not a strange layer, a buried object, or a chemical signal. It is the absence of one. The evidence supplied for this investigation contains no dated sediment layer, no crater, no impact material, no archaeological assemblage, and no scan result tied to the Younger Dryas Impact Hypothesis. That matters because the title asks, what is wrong with a specific explanation of the past? Answering responsibly requires more than the possibility that objects from space can affect Earth. It requires a chain connecting a proposed celestial event to physical traces, reliable dates, and documented consequences. That chain is not present here. So the first concrete answer is also the most important. With this evidence alone, neither the impact hypothesis nor the arguments against it can be validated. The available material establishes only a broad scientific context. Astronomy is the natural science concerned with celestial objects and phenomena originating beyond Earth's atmosphere. Its objects of study include meteoroids, asteroids, and comets, alongside planets, stars, and galaxies. Astronomy uses mathematics, physics, and chemistry to explain how such objects behave and evolve. This confirms that potential impactors are legitimate subjects of scientific investigation, but it does not document a particular impact. A general description of comets and asteroids cannot identify when one struck Earth, where it struck, what material it deposited, or whether it altered climate and human societies. The distinction is basic, but decisive. A known class of celestial object is not evidence for one proposed prehistoric event. That reveals the hidden constraint behind the controversy. A claim about a cosmic event in human prehistory crosses several kinds of inquiry, but the supplied record covers only one of them in general terms. Astronomy can examine objects beyond the atmosphere. An archaeological argument, however, would also need relevant material from human contexts. A geological argument would need an identified deposit and a defensible sequence. A chronological argument would need dates attached to those observations. None of those Younger Dryas-specific elements appears in the evidence provided. Even the phrase accepted timeline cannot be reconstructed from this material because no timeline for the proposed event, environmental change, or archaeological consequences is supplied. Without those components, the investigation cannot move from cosmic possibility to historical explanation. The first attempt at evaluating the hypothesis must therefore be an inventory. Is there a named object that allegedly arrived from space? The evidence does not identify one. Is there a location where its effects were documented? None is supplied. Is there a physical layer containing material interpreted as impact debris? No such layer appears. Are there measurements, analytical results, or competing laboratory interpretations? They are absent. Are there dates showing that the proposed signal and the event under discussion occurred together? No relevant dates are given. Most importantly, there are no primary studies, institutional findings, or independent reports addressing the hypothesis itself. The inventory does not prove that no such evidence exists elsewhere. It proves only that it is missing from the record we are permitted to evaluate. The turning point comes when apparently related material is tested for relevance. The source discusses prehistoric interest in the sky. Stonehenge is presented as evidence of ancient astronomical observation. The Nebra Sky Disc contains symbols interpreted as the sun, moon, and stars. Arrangements at Nabta Playa have been connected with calendrical observation and the rising of Sirius. These examples show that people observed celestial patterns long before modern astronomy. They do not show that those people witnessed, recorded, or survived the event proposed by the Younger Dryas Impact Hypothesis. Connecting them would require evidence that has not been supplied. Ancient attention to the heavens cannot substitute for an impact deposit, and a symbol interpreted as a star cannot be converted into a record of catastrophe merely because both subjects involve the sky. This is the mechanism of the evidence problem. A large claim can seem supported when several different propositions are allowed to blur together. Asteroids and comets exist. Astronomy studies them. Ancient communities watched the sky. Archaeological sites preserve traces of that interest. Every one of those statements is compatible with the supplied source. But the conclusion that a particular object caused a particular prehistoric disruption does not follow from them. The missing steps would have to establish the event, its timing, its physical signature, and its consequences. Each step would also have to survive alternative explanations. If those links are skipped, broad truths about astronomy create an atmosphere of plausibility while doing no direct work on the disputed historical claim. That gap has consequences. Without site-specific evidence, the proposed event cannot explain an archaeological change. Without relevant measurements, unusual material cannot be assigned to an extraterrestrial source. Without dates, two observations cannot be shown to belong to the same episode. And without competing analyses, disagreement cannot be described fairly. A dramatic explanation may still be imaginable, but imagination is not the same as documentation. The danger is not simply that one side might be wrong. The deeper danger is that viewers may be offered certainty where the available record supports only a question. In archaeology, that can turn gaps in evidence into spaces for speculation, while the people and material cultures actually represented at sites become secondary to a catastrophe story that has not been demonstrated. There is an important counterpoint. The absence of Younger Dryas specific evidence from this dossier is not evidence that celestial impacts never occur. The supplied source plainly identifies asteroids, comets, and meteoroids as real objects studied by astronomy. Nor does this audit establish that the named hypothesis is impossible. It establishes a narrower conclusion. No judgment about that hypothesis can be responsibly derived from the material provided. That distinction protects inquiry in both directions. It prevents general astronomical knowledge from being presented as confirmation, but it also prevents an unsupported declaration that the proposal has been conclusively disproved. The uncertainty here is not a mysterious feature of the ancient past. It is a documented limitation of the available evidence. So where does that leave the question today? Within this evidence set, the current status cannot be reconstructed. There is no supplied history of the hypothesis, no description of its proposed mechanism, no list of supporting observations, no record of replication attempts, and no account of expert responses. We cannot say which claimed indicators remain disputed, which have been reinterpreted, or whether any particular result has gained or lost support. We also cannot quantify acceptance among astronomers, archaeologists, geologists, or other specialists. Any narration that supplied those details would be importing knowledge from outside the approved record. It might sound authoritative, but its evidence chain would be invisible, and that would reproduce the very problem the episode is supposed to examine. What, then, is wrong with the Younger Dryas Impact Hypothesis? On the evidence supplied here, that question has no defensible hypothesis-specific answer. The record demonstrates that astronomy studies possible impactors and that ancient societies observed the sky. It does not connect a celestial object to a Younger Dryas layer, establish a date, identify an impact signature, document a causal mechanism, or show an archaeological consequence. The responsible conclusion is therefore not that the proposed impact certainly happened, and not that it certainly did not. It is that the necessary evidence chain has not been presented. The lesson is consequential. Before a cosmic explanation can change our understanding of prehistory, every link must be documented independently. Possibility begins the investigation. Only relevant, dated, reproducible evidence can finish it. Visual reconstructions are illustrative. Facts and interpretations are based on the sources listed in the description.